so here's another question for us. They said, how many atoms are there in 0.8 gram of oxygen molecules? Now take notes, atoms in this. Okay, so the first thing we do, remember the part of the formula that say if it concerns particles, and this is particles, right? How do you know it carries times 10 raised to power, which is Avogadro's constant? So we know that it is mole over number of particles over Avogadro's constant, which is 0.6.02 times 10 raised to power 23. Now, what is the mole? The mole is not given, but so we cannot start using this formula immediately. What do? Remember they gave us grams, right? Mass. So we first of all recall the formula that says if mass is given, it is mass over molar mass. Now, what is the mass given there? We have 0.8. What is the molar mass? Now, a lot of students will make mistake here. Oxygen is diatomic, which means it exists like this in nature. It is diatomic. So they gave us one parameter of oxygen to be 16, right? So that means since oxygen exists like this, it is 16 times 2. Out together. So 16 times 2 gives us 32. So therefore this is 0.8 divided by 32. 0.8 divided by 32 is 0.025 mole. So we've calculated for our mole. That means we cannot come back to this one. So the reason why we did not solve through this one, using this one, is because we cannot solve for two unknown, right? Now we've gotten the value of mole, so we cannot solve. Now recall for composition of stoichiometry, because they ask us to calculate how many atoms are there. How many atoms? Atoms in oxygen here is 2, right? Because 2 here is acting as a subscript. Molecule in oxygen here is 1 because there's nothing at the front, so we assume it is 1, right? So before we can solve with this, we have to multiply this with 2 times 2. So if we did multiply that times 2, so we are going to get 0.05. Now we cannot solve. So we now have the mole, which is 0.05 mole, is equals to the number of atom or particles we don't know over Avogadro's constant. Over Avogadro's constant. Now, how do we go about this? Now, use this, of course, we know we cross multiply. Now, use this to multiply this. So we have 0.05 times 6.02. So this now becomes 0.301 times 10. Just bring this one down. All over 20 times 10 all over 23. Now, if you look at these options, you see that we have like this, and this is the answer we got. So what did they do? What did they do? So look at me. Now this 0, this point, we want to move it here, right? We want to move this point here. So this will now become 3.01 times 1023. Now, because we are moving these points backward here, we have to subtract 1 from here. So If we subtract 1, this will now become 3.01 times 10 raised to the power 23. So if you look at the options, we have 1.5, 3.0 raised to the power 23, 3.0 raised to the power 22. So this is the answer. Here's another question, and it's the final question for Stoichiometry, and I encourage you all to check your materials for more questions and join our community, because in our community we are going to solve a lot of questions on Stoichiometry. Now they said, what is the concentration of a solution containing 2 grams of this in 100 cm cube of solution? Now let's bring out our parameters. So they gave us 2 grams, they gave us a compound, they gave us volume, right? Now remember, what should be at the back of your head is that whenever mass, which is gram, is given, just recall this formula that says mole is equals to mass over molar mass, which is equals to 2, right? So what is the molar mass? We have this compound, sodium hydroxide. So we have 1 sodium plus 1 hydrogen plus, 1 oxygen plus 1 hydrogen. So this is 23 plus 16 plus, this is 1. This is 1. So this is 40, right? So this is 40. So 2 over 40 is 0.05. Now, what did they ask us to calculate? Is not the mole. They ask us to calculate for concentration. What is the formula that is making concentration and volume? Is mole is equals to concentration times volume, right? So we just calculated our mole to be 0.05. Concentration, let's say concentration is conc, we don't know, times what is the volume. Remember, this is in centimeter cube, cm cube. We have to convert to dm cube. In so doing, we divide by 1000. So if we divide this guy by 1000, so this is 0.1. So times 0.1. Now, of course, we can divide through by this guy 0.1, or we can say this is 0.05 equals to 0.1 conc, right? So we divide, so therefore conc is equals to 0.05 divided by 0.1, which is equals to 0.5 mole per dm cube. Now, if you look at the options, jump question, they give us number 1, A is 0.4 mole per dm cube, B is 0.5 mole per dm cube, C is 0.00 mole per dm cube, then D is 0.3 mole per dm cube. Of course, our answer is B, smash.